Hello and welcome. In this video, we're going to talk about slope fields. We're going to talk about how a slope field is a visualization of the solution to a differential equation. So our objective in this lesson, I can create and use slope fields. Let's go ahead and jump right in. In the last video, we talked about what a differential equation is, and a differential equation is just an equation that contains a derivative. Similar to the one written right here, y prime is equal to 3xy. So y prime being the derivative is what makes this a differential equation. What differential equations do is the derivative is the slope. A differential equation models the slope of different tangent lines at different points or different values. So for example, if we wanted to know what the slope, the derivative is the slope, what the slope was when x is -2 and y is +2, we would plug in -2 and +2. We'd multiply them together and multiply by 3 to get -12. In previous chapters, we talked about how tangent lines do a great job of approximating a function as long as we're really, really close to the value we're trying to approximate. So locally, tangent lines do a great job of approximating the shape of a function. So if we found a bunch of little teeny tiny tangent lines and we created them or we plotted those slopes on one graph, so here's the slope and here's the slope, and each of these little blue tick marks is a slope, that would give us a good visual of what the solution to the differential equation is. Each of these blue lines is representing a slope at a different xy coordinate, and you can start to see the shape. This looks like a circle, or if we're talking a function, a semicircle of a graph. This is called a slope field. So a slope field is a graphical representation of a variety of different slopes or a set of different slopes when you plug those values into a differential equation. If you want to talk about a particular solution, then you could create a slope field and you could sketch almost like you're staying in the bumpers, like you're playing bumper bowling here, to sketch a particular solution to a differential equation. So here on top we have a slope field, here on the bottom we have a different slope field, and in red you have the solution to a particular solution to the differential equation. Now that we have an idea of what a slope field is, let's talk about actually creating one. All right, here we have the differential equation dy dx is equal to -x over y. And we have a blank graph for a slope field. So each place that there is a dot, we are going to find the slope that corresponds to that coordinate by plugging in the correct x and the correct y value. So let's actually start with all of these points or dots first. So for all of those dots, x is equal to -1. So in my first table, I'm going to create x values of -1. When x is -1, we care about what happens down here. So when y is -2, when y is -1, when y is 0, when y is 1, and when y is 2. So basically, I'm going to plug in each of these points into this differential equation to find the slope, which is the derivative. Okay, so if we plug in -1, -2 into -x over y, we're going to get -1/2. If we plug -1 into -x over y, we're going to get -1. If we plug in 0 for y on this next point, this is not going to exist because we can't have 0 in the denominator. If we plug in -1, 1, we're going to get +1. And if we plug in -1, 2, we're going to get 1/2. So I'm just plugging each of these coordinates into this differential equation to find the slope. Now we need to do that exact same thing for all of these coordinates and all of these coordinates. So when x is equal to 0 and when x is equal to 1. Okay, so if I plug in 0 for x, as long as y isn't 0, 0 over -2, 0 over -1, 0 over 1, 0 over 2, as long as y isn't 0, this derivative is going to be 0 if x is 0. And if y is 0, it's not going to exist. There we go. So if we're looking at the last one, if x is 1 and y is -2, we're going to get +1/2. If x is 1 and y is -1, we're going to get +1. Again, this isn't going to exist if y is 0. If we plug in 1 and 1, we're going to get -1. If we plug in 1 and 2, we're going to get -1/2 because we're simply taking all of our x values and dividing them by -y. So now what we're going to do is we're actually going to sketch the slope that we found for each coordinate on that little dot. So this dot here, -1, -2, the slope is approximately, or the slope is -1/2. So what I want to do is I want to visualize what it looks like. So from here to here, that would be the slope down 1/2. That would be the slope -1/2. So I want to use a straight edge, which I really can't do here on this video, but I want to use a straight edge to create a slope like that, and I want to draw that right here. Then at the point -1, -1, the slope is -1. So I almost want to draw a slope like I'm trying to connect these 2 points here. And I'm just drawing a little teeny tiny tick mark with a slope of -1. So a slope almost as if I were going to connect these 2 dots here. At y equals 0, so for -1, 0, I'm not going to draw anything because the slope doesn't exist there. So I'm just going to leave this empty. Up here at -1, +1, at -1, +1, we have a slope of 1. So we're going to draw a slope as if it were passing through these 2 points, but just representing it as a little tick mark here. And lastly, for that far left, when x is -1 and y is 2, we're going to have a slope of +1/2, which is going to be like I'm connecting, like I'm going down 1 and over 2 to create a slope. When x is equal to 0, the slope is going to be 0. That's going to just look like a horizontal line segment. We just need to make sure that we don't include 0, 0 because y is not allowed to be 0. And then when x is equal to 1 and y is equal to -2, we have a slope of +1/2. So again, we're trying to make that look like down 1 over 2. When x is 1 and y is -1, that's a slope of +1, so we want to make that look like we're connecting down to -2. We're going to skip the x-axis because y is not allowed to be 0. At 1, 1, we're going to have a slope of -1. So we're going to look like we're connecting the dots to get a slope of -1. And last but not least, that top point is going to have a slope of -1/2. So we want to connect it as if I'm going down 1 and over 2. And now we have created a slope field, and we can see that the derivative doesn't exist when y is equal to 0, so we could get an idea. This kind of looks like half of a circle maybe, or a semicircle, some sort of curve when we look at this slope field. So again, the idea of a slope field is creating a visual where if we connected these slopes together, we could get an idea of what the original function or the solution to the differential equation looks like. Let's do a couple more practice problems. All right, so here we have the differential equation, y equals 1/2 of x squared. We are again going to plug in different values for x and y, so the table is preset if you need to pause the video and fill that in on your own. And then what I want you to notice for this one is that actually there is no y in this differential equation. So it doesn't matter if we're at -1, -2, or -1, -1, or -1, 0. When we plug in -1, what is the slope going to be? -1 squared is 1 times 1/2 is 1/2. So every single one of these values, if x is -1, is going to have a slope of +1/2. Similarly, if x is equal to 0, it doesn't matter what y is. 0 squared is 0 times 1/2 is 0. So all of these slopes are going to be 0. When x is 0, the derivative is 0, regardless of what the value of y is. And then lastly, if x is 1, we're going to get, again, 1/2 because we're squaring +1 and multiplying it by 1/2. Regardless of what the value of y is, the slope is going to be 1/2. So this slope field should be pretty easy to create. We're going to find the angle for 1/2, so up 1 over 2, and then we're going to use that for everything over in the -1 column and everything over in the +1 column, and then the slope for each of these values is going to be 0 along the y-axis. So go ahead and pause the video and sketch each of those slopes, and then unpause the video and see how you did. And there we have the slope field for this differential equation. Let's do one more example together of creating a slope field. For this last example, the derivative is only impacted by y. So we actually just really care about what happens when y is -2, what happens when y is -1, what happens when y is 0, what happens when y is 1, and what happens when y is 2. So we may not actually need to worry about filling in this table completely, because really we just care about what happens. Actually, let's manipulate one of these tables and just make it completely in terms of y. Actually, we're just going to use just this bottom table. If y is -2, regardless of what x is, the slope is going to be -1/2, because 1 over y is going to be -1/2. If y is -1, the slope is going to be -1. If y is 0, the slope is not going to exist. If y is 1, the slope will be 1. And if y is 2, the slope will be 1 over 2. So that means everywhere horizontally, you're going to have the same slope going across. So go ahead and pause the video and try and complete the graphical part of the slope field on your own. And there we have our slope field. So in creating slope fields, we're thinking about different coordinates. We're finding the slope, or we're plugging that coordinate into the differential equation, and then we're sketching little teeny tiny slopes at those values. Make sure you write down any questions you have, and we're going to look at just one more example. All right, for this very last question, we're going to focus on already having the slope field and trying to figure out what the differential equation that it's representing is. When I do this, the first thing I like to do is I like to look at 0, 0, because it's usually pretty easy to plug 0 and 0 in. At 0, 0, what I notice about the slope is that it's definitely positive, and it looks like it's about +1. So if I were to connect that looks like it's a slope of about +1. So if I plug 0 and 0 in to any of these equations and I don't get +1, that can't be the solution to the differential equation. So that's going to eliminate A, because if I plug in 0, 0, I get that y prime is 0. Similarly for B and for C. So those three options don't make sense as a visualization of this differential equation. The next thing I'm going to do is I'm going to pick a different point. So maybe 1, 0. If I plug in 1 for x and 0 for y, that slope still looks exactly the same as it did at the origin. So it still looks like it's +1. So looking at these last two equations, if I plug in 0 for x, if I plug in 1 for x and 0 for y, I should get a slope that is +1. Well, if I plug that in here, I would get that y prime is going to be 2. If I would plug that in here, I would get that y prime is going to be 1. So I'm feeling like it's probably E, but let's look at one more point just to maybe be a little bit more sure. If I plug in 2, 0, I should again have that same slope that looks like it's about 1. If I plugged that in here, I would get a slope of 5, which would be very, very steep to be able to go up 5 and over 1. So D isn't going to make sense as the answer, and E is. So if you're given a slope field itself, really pick out different slopes and plug those in and see if you can narrow down the options to get to the correct answer. You won't be actually writing the equation of a differential equation from a graph, but potentially having to match slope fields and differential equations, or a multiple choice question like this where you're just trying to figure out what the differential equation being graphed is. All right, let's go ahead and wrap up this video. Our goal in this video was to be able to create and use slope fields. We talked about what a slope field is, how to create an XY table so that we can sketch a slope field by drawing those teeny tiny slope lines, and then how to look at an already given slope field and narrow down which differential equation it might be representing. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.